Hello everyone, welcome to Physics CQ-METANS. This is the third video lecture on vector analysis. So this is what I'm going to discuss in this video. I'm going to discuss only just lines and planes in this video. So now what is a line? We already know that an equation of line is y is equal to mx plus c, where this m is the slope and the c is the intercept. Now we have to see the line in vector perspective. So how we can define a line? If I have a line vector in the coordinate system, so how can we find out the equation of that vector and so on and so forth? So now if I have this xyz coordinate system, so this is my x, y and z coordinate system. Now if I have any point in this xyz coordinate system, so this coordinate, so I will represent this point as x, y and z in this coordinate system. So now if I draw a vector r like this, so this head of the vector will be at the point x, y and z, while the tail is at origin. So this vector r, I can write it as x I cap plus y j cap plus z k cap. So this is what we can write. So remember that the tail is at origin. So this is what we have written over here. So this point we will consider the head of the vector. So this xyz is considered as the head of the vector and the tail of this vector is at origin. Now we will take an vector A whose coordinates are 2, 3 and 5. So this represents the x component, this represents the y and this represents the z. So same as the graph. In graph also we take this coordinates and plot it accordingly. So in the same way this x and y and z, this bracket represents. So vector A will be then along x it is 2, so it is 2 I cap. So along y the component is 3, so it is 3 j cap, and similarly for z it is 5, so it is 5 k cap. Then the vector b is equal to r minus a. So how this comes from? So if you remember, we studied the law of vector addition, the parallelogram. So the head and the tail of the vector, if it is aligned, so I can write vector a plus vector b. So now if you see, the head of the vector and the tail of this vector b is, so the tail of the vector b is sitting at the on the head of the vector a. So if I draw any vector, so that will give me the addition of these two vectors. So if I rearrange this, I will get this equation. So this is r, that is this vector, and this is the a vector. So if I subtract them, now from this addition and subtraction of vectors, we know that if I subtract two vectors, then their components get subtracted. So this is x minus 2 I cap plus y minus 3 j cap and z minus 5 k cap. So this is from the subtraction of vector. So this notation, let me tell more about this because we will be using this frequently. So if I have vector 1, 0 and 2, so this is the x1, this is y and this is the z component. So I can write along x means I cap. So it is 1 I cap plus 0 j cap plus 2 k cap. So 0 we don't write, like 0 k cap writing is nothing, it is meaningless. So we write it as I cap plus 2 k cap. So similarly, if I have this vector minus 2, 4, 0, so I can write it as minus 2 I cap plus 4 j cap. Similarly, you can find out this one. Now in 2 dimensions, we write the equation of straight line as this: y minus y naught divided by x minus x naught is equal to m. So let us do some vector algebra and see whether we land up with this equation or not. So Now suppose instead of a slope, we have a vector. So that is given by x is equal to ai cap plus bj cap. So if this is my vector A, now we know that the components are there. We have the components. And when we define the slope, what we do is y by x. So this is the A component. Now see, along I cap, I have A. So this is A and this is B. So rather than slope, if I define a vector A in such a way, then now if I take a line in the direction of A, so this line I am taking it over here in the direction of A. So this is the line. Now the coordinates of this line, let us define it as x naught over here, y naught over here, and this is equal to r naught, and xy over here, and let us define this point as r. So this vector will be r minus r naught. So r minus r naught will be, so this r minus r naught we have written over here. So that is x minus x naught I cap plus y minus y naught j cap. So I'm drawing a line segment from this point to this point. So this is just in order to show that these two are in a straight line. So this is what the vector r minus r naught represents. So now if you see, then vector A and this vector r minus r naught are parallel. So the angle between them is 0. So if I take the dot product, I know if I have two parallel vectors, then their components are proportional. So we have already seen that if I have parallel vectors, then I can write one vector as a scalar multiple of some another vector. And sorry, this is y. So we can write like x by y is equal to k. We have written this. So and then we get this equation that x minus x naught divided by a is equal to y minus y naught. So actually this was a, then it was y is equal to k times b, and then we wrote this that y by a is x by a is equal to k, y by b is equal to k. So all three are equal to some scalar multiple, so their components we can write it as they are equal. So their components are proportional. So now if this is through two-dimensional, so two-dimensional, so that is why I can write x minus x naught divided by a, that should be equal to y minus y naught divided by b. Now if I want to incorporate this in the three dimensions, so I will write z minus z naught divided by c. So this is how we'll end up with this equation. Now if we just omit this part, just we take this one. So if I interchange this, so I get y minus y naught divided by x minus x naught is equal to b by a, that is equal to m, and this is a straight line, the equation of straight line, which we already have seen. We know this. So with the vector also we can find out the equation of straight line. Now it is not necessary that like it should be in this straight line, it should be parallel, that's it. So we will come with the transformation of vector when we will study this tensor analysis. So in that you will come to know what the transformation of vector is. So if I translate this vector, so if this is a vector A, so if I take this vector and draw it over here, so the same with same magnitude, so the direction remains same. So this is invariant under translation. So we will see what this all terms mean. Now another way for this line is to parameterize. Now parameterize is very important. So for instance, we will study this. So if I have some curve, now we are talking about line, so we will not emphasize more on this one. So if I have a curve, so I can always parameterize this. So when we will study this STR and GTR, special theory and general relativity, at that time we will see how this parameterize is important. So if we have this vector r minus r naught and a, if these two vectors are parallel, Then as I mentioned, we can write one vector as some scalar multiple of other. So I am writing this r minus r naught as equal to some scalar multiple of another vector, that is a times t. So just rearranging the equation, I get r is equal to r naught plus at. But this t is some scalar multiple. It is not, don't get confused, it is a time. It is just some scalar. If you don't like putting t, put some arbitrary, say w or anything scalar. So now the components are proportional. Sorry, we can write now if I take the components. So this r minus r naught can be written as x minus x naught I cap plus y minus y naught j cap, that is equals to at. A is what? A I cap plus b j cap times t. Now if you notice, then this x minus x naught should be equal to a times t. So we can write x minus x naught is equal to at. So these equations are already written over here. So this is where, so their components can be written as x minus x naught is equal to at and y minus y naught is equal to bt. So this is what we get. Now if we eliminate t, so how can we eliminate t? So just over here, if I do y minus y naught is equal to bt, and if I divide this by another equation, that is x minus x naught divided by at, so this t gets cancelled. So if you see, this t will get cancelled, and what we are left with is y minus y naught divided by x minus x naught is equal to b by a. That is what we get. This is the equation of a straight line. So if I write in 3 dimensions, so this will be the equation. So this parametric equation is useful. Now say if t is this parameter t, we call it as time. So this equation will become this. So rearranging this equation, we will get this part. Now if I have a particle of mass m moving in a straight line, so that particle starts from r naught at t is equal to 0 and it reaches at r is equal to this r naught plus at at some time later time t. Then if we differentiate this equation with respect to t, we will get dr by dt is equal to a, which is the velocity of that particle. Next is the plane. Now suppose we want the equation of straight line. So now this is the straight line and we want to write the equation of the straight line, and this is some normal vector. This is some normal vector. So we want the equation of straight line L through a point x naught and y naught and perpendicular to a given vector n, that is a I cap plus b j cap. So I can write, so r minus r naught will be x minus x naught plus y minus y naught that lies along the line L. Now we want this vector perpendicular to n. So this L should be perpendicular to n. So this r minus r naught should be perpendicular to n. So that r minus, sorry, r minus r naught dotted with n, vector n, is equal to 0, because the dot product of two vectors, parallel vector, perpendicular vectors is 0. So if we see, so r minus r naught is this. So if I want to write, so this is x minus x naught I cap plus y minus y naught j cap dotted with this a I cap plus b j cap, and that should be equal to 0. So I get x minus x naught times a plus y minus y naught times b. So if we rearrange this equation, we will get this. Now if I take this angle as theta and this angle as phi, so this n is a vector. So the components we know, the components are, so this is the component b and this is my component a. So this tan, or say cot phi, if I want to write, so cot phi is nothing but a by b, and if I plug a minus sign, then I will be consistent with this equation. So the slope of the line is minus cotangent of theta, that is equal to minus a by b. That is what we get. So now this is two dimension. So this, from this we get some understanding. Now let's suppose if I have a plane. So this is a plane. Now this is very important. Now three dimensions, we are extending it to three dimension. We use the method to write equation of plane. Now same equation, same method we will write. We will use to write the equation of plane. Now if x naught, y naught, z naught is a given point in a plane. Now this plane is in the xyz coordinate system. Now say if I have this point which is defined as x naught, y naught and z naught. This is defined as x naught, y naught, z naught. So this point is on the plane. Now and x, y, z is another point in the plane. So there is another point over here whose coordinates are x, y and z. Fine. So the vector, now the line joining these two vectors, these 2 points, sorry. So this will give me, say, r minus r naught. Say this is some r naught point, this is some r. So I am getting this as r minus r naught. So the vector r minus r naught, that is x minus x naught I cap plus y minus y naught j cap plus z minus z naught, is in the plane. So this line which we are drawing, this is in that plane itself. So if n is normal to the plane, so if I draw one normal to the plane, so you say this is the normal vector to the plane. So this, just think of it that you have a book and on the book you have placed your pen vertically. So the point of this pen is pointing towards the ceiling. So that will be the normal vector. So this normal ai plus bj plus ck is normal to the plane. Then this vector n and r minus r naught are perpendicular. So we know what to do with this perpendicular vectors. So we get a times x minus x naught plus b times y minus y naught plus cz minus z naught is equal to 0. Or we can write it as ax plus by plus cz is equal to d, where d is this. So this is the equation of plane. We will use this, we will solve problems on this, you will understand it more neatly. So next video I will be posting on the problems which the problems covering the concepts which we have covered till now, that is the scalar product, vector product, this lines and planes. So that's it for this video. So thank you all for joining me. So see you all in the next video. Thank you. Thanks a lot.